Hello everyone. So we will get started. So here the agenda for today's webinar is to give you a basic introduction to different types of graphs and charts that can be created using Tableau. Now Tableau is a tool that is used for the purpose of data visualization. And how is the program or the course designed? If you enroll for Tableau training with Edureka, then the overall project is designed, the course is designed as 12 modules. Module number 1 is data preparation using Tableau. How do you prepare your data for analysis? Then how do we connect to various data sources from Tableau desktop? We have a module where basic visual analytics, like creating basic graphs in Tableau and all, are introduced. Then there's a module on calculations. So how do we write a formula? What if we have to manipulate the data? How do we do it? Then we have a module called as advanced visual analytics. What are the analytical capabilities present in Tableau? That is what we cover here. Though Tableau is primarily a data visualization tool, we can do amazing things even on the analytical front. That is what gets covered here. Module 6 is on something called as level of detail expressions in Tableau, which is nothing but calculations only, but they are special type of calculations which behave slightly differently. They're completely different from any other regular languages that you might be aware of. So we will be covering them in this module. And there is module 7, which talks about the geographic visualizations in Tableau. Everything about how to use geographical data, how to map it on the background geographical map, all that gets covered. Then there's a module where advanced charts in Tableau are covered, some of which we will also be seeing in today's class. Then there's a module on dashboards. Dashboard is nothing but a report. Finally, we have a module where you will be given a project to work on, which is like an industry grade project. Okay, after this, there is also a module where we talk about Tableau server or Tableau online. Okay, and there is one in-class project that we will solve in module number 12. Okay, so this is how the overall course is designed. If you register for the complete training, this is what you will get. Tableau is basically a tool that is launched by a company named Tableau itself. The name of the organization, the company that launched Tableau, is Tableau itself. And it is one of the largest tools that is used for the purpose of data visualization in the field of business intelligence. If you look at its architecture, so this is Tableau. Imagine this person is working on Tableau. We can connect to various data sources from Tableau, create the reports, and after creating the reports, there are many ways in which we can send it to other people. We can send it to information customers in the form, a report created on Tableau can be sent out as a PDF document. A report created on Tableau can be shared as a PPT. It can be shared through an Excel. The data can be shared through an Excel or a Word document. It can also be published on Tableau server, which is very secure. Okay, so whatever you create on Tableau, we take data and create the reports. After creating the reports, we share it with other people who need it. And we have a variety of options when it comes to sharing the reports with end users, with the stakeholders. Talking about the features of Tableau. First is it is an amazing tool when it comes to data visualization. And it also falls under the bucket of self-service BI tools. So there are certain features that the end user can directly use from Tableau. It is very user friendly, easy implementation, basic requirements. People can directly work by themselves. Even when you deliver a graph to somebody, they can make some modifications to it, even though they might be looking at it for the first time. It is that user friendly and simple to work with. It supports integration to a wide variety of data sources. From Tableau, practically you can connect to any data source that you want. And mobile support is there. There is one app called as Tableau Mobile, which again is a free app, which can be downloaded on the mobile phones, and reports created in Tableau can be accessed through that app. And there is an online community which you can join and be a part of the Tableau team. Okay, there's a forum. Now, there are something called as generated fields in Tableau. I will tell you about this by creating a graph. So when you open Tableau, this is what the interface will look like. And then to connect to any data source, you just have to choose the name of the data source. As you can see, the list is quite extensive. You can connect to any of these data sources listed out over here from Tableau. very rich data connectivity capabilities are there, integrating with different data sources. So after choosing the type of the data source, you can actually go ahead and choose the file itself. And after that, we tell Tableau exactly from which table or sheet we would like to use the data, post which we can go to the worksheet. Or even if you don't want to do this, there are some data sources which are inbuilt into Tableau. They're already shipped. When you install the tool, you get the data sources called as Superstore and World Indicator. So you can just select Superstore and connect to it. And you can use this data source for practicing some concepts on Tableau. Okay, it's a data source from the retail industry. Now let us say my requirement is to create a simple text table. We'll talk about generated fields. There's something called as measure names and values and number of records or count. I will mention about this latitude, longitude. I will tell you. So we will first create one simple chart and then try to understand it. Let's see how to create a simple bar graph here. Bar graph is something that is used to perform comparative analysis. It is used to compare the data. Let's say across different regions, how is the business doing? Which product is selling the most? Which product is selling the least? Okay, which region is the most profitable? Which region is the least profitable? At a glance, it will reveal the highs and lows in the data. It helps you to perform relative comparison. That is why we need a bar graph for relative comparison. Now, how do you create a bar chart? You can, let's say my requirement is to look at profit from different categories. There are different categories of products being sold. So I'll take category to the rows shelf. Now, when you take something to rows, you are asking Tableau to show the data from that field as a row. Okay, there are 3 categories. Each category is appearing as a row. Then I would like to show the profit, which I'm taking to columns. When you take something to columns, you're asking Tableau to show you the data from that field as columns, cutting across columns, 10K, 20K, 30K, 40K. It is cutting across columns. Okay. Now the same thing, suppose I interchange it. Categories on the columns shelf. So the members in that field will appear as a column. Profit is on the rows shelf. Data from that field will cut across rows, 10K, 20K, 30K, 40K. This is a bar graph. At a glance, it is revealing the highs and the lows. I'm able to understand that office supplies is better than furniture, but it is not as good as technology. Relative comparison. That is when we go for a bar graph. Okay. Now let's say here, I would like to show the profit or I would like to show the profit and sales, okay, together across different regions. I want to show the profit, and next to it, I would like to show sales also. I'm going to take region, select profit and sales, or let me do it like this. So I'll take region to the rows, columns shelf, okay, and I will take profit to the rows shelf. It is a simple bar chart. West region is the best performer, south, and then you can see central with the least profits. I would like to look at sales. So I'm taking sales here. Sales comes up with its own axis as another chart. Now, what if I want both of them to be combined together? What if we have to show them side by side with a single common axis? Separate for profit, separate for sales is what we are seeing, but I want to bring them together. So in that case, we can go with something called as a side-by-side bar graph. This one. This is called the Show Me panel, which has a lot of graphs in it. And you can create charts very easily from the Show Me panel. You just have to click on the graph. Now look at what is happening. We are having a common axis, which is holding data about both profit and sales. They are merged here. And you have profit and next to it is sales. Then profit and sales from each region. So side by side bars. And here we are using multiple measures, right? So when you use more than one measure with a single axis, Tableau will use something called as measure names and measure values. These are called generated fields. When you get connected to any data, okay, from any data source, Tableau has access to the information in each and every field from that data source. So it knows what is the discount offered. This is present in your data source. It knows what is the profit. It knows what is the number of products sold, quantity. It knows about the sales information. But it also automatically generates a few fields which will help us. What are those fields? First is count. Count will tell us about the number of records. Okay, now I'm taking count here. In total, we have 9,994 records in this particular data source. Total number of rows is 9994. That is what count will tell you. Then another generated field is measure names. It contains the names of the measures. What are measures? Numerical data like discount, profit, quantity, sales. These are called measures, containing some quantitative information in them. So measure names is a field that contains the names of these measures. And measure values is a field that will contain the data in these measures. Okay. See, profit has information about the profits made by the business. Selling price of the products, the sales from every transaction is there in sales. Number of products sold, quantity is here. What is the discount offered is here. But measure values has all this data put together. It knows everything about the discount, profit, quantity, sales, each and every measure. Okay. These are automatically given to us by Tableau. They are called generated fields. Will come with a slanting font. That's how you recognize them. Fields from your data source are like this, but what the ones which are generated, they come with a slanting font. Okay. So when you create a graph with multiple measures, Tableau will automatically use measure names and measure values wherever applicable. It's applicable here, it has used it. Let me do a text table first, then I will show you another application of measure names and measure values. Let's say I'm looking at, let's say I want to look at the profits from various subcategories in the form of a text table. So I'll take here profit. You can see Tableau has automatically given us information about the profit made by different subcategories. I would like to show sales also in the same graph with a common members, common header. So when I take sales into the graph, what happened here now? Tableau is showing us information about two different measures. So because we are showing multiple measures with a common header, like in this case, multiple measures with a common axis. Here, multiple fields with a common heading. Common heading. This is accessories. It's the heading of this row. Appliances, the heading of this row. Okay. So in such cases, Tableau will make use of measure names and measure values. So how are the data values appearing? Text. So you can see it is on text. And what is measure names? Why is it on columns? Because we are showing profit as a column and we are showing sales as a column. What if I bring it to rows? It will show profit as a row and sales as a row for every subcategory. Okay, so that is the purpose of generated fields. Whenever you're creating a graph with multiple measures with a common header or multiple measures with a common axis, in such cases, Tableau will use generated fields. Measure names and measure values. Count is simply the number of records. Okay. So let's go to the next chart. This is a line chart. Now, when would you create a line chart? Line chart is used when you have to show the performance of a business over a period of time. Bar graphs are used for relative comparison. Side-by-side bars are when you're comparing performance of different measures against each other. What is sales and what is profit? Two different measures are being compared. Which one is higher, which one is lower? Text tables are created when you have an eye for detail, especially when you're dealing with money. Like all the statements that we receive, like the bank statements, credit card statements, profit and loss statements of organizations, balance sheets, utility bills, the electricity bill, the water bill, right? If you go to a retail store and purchase something, then the bill or the check that you receive. So these are all basically text tables only. They're all where money is involved. And when money is involved, we would like to know the exact value down to the last penny. So that is when text tables are created. Now, line charts are created when you have to show the trend over a period of time. Okay. So when you have time series data that has been collected for over a period of time, and you would like to see the performance of the business across those units of time, okay, across different years, what is the profit like? Then we create a line chart. So in this case, you can notice that year over year, the profit is increasing. Now we can drill down and look at the performance by quarter. We can look at the performance by month. However you want, you can create the graph. And yeah, we can do forecasting as well. So I have time series data. Now I would like to forecast, estimate what will be the profit like in 2022. So all I have to do is go to this analytics pane and drag the forecast option and drop it here. Tableau will automatically perform the forecast and show you the result. Okay, so let me show it with sales. Sales forecast. There is a seasonal pattern when you go with sales. So we can do forecasting, we can do estimation for the future as well. Okay, line charts are created like this. What is the prerequisite to create a line chart? You need time series data, you need information for different years gathered and put together, and we are visually representing that through a line chart. There's one more graph called as a Pareto chart. This is actually a little advanced chart, but I'll try to show it to you. Pareto is built on the Pareto principle. It is usually to see whether Pareto principle holds good or not. It is a chart where, and what does the Pareto principle say? Pareto principles is called as the 80-20 rule. It says that by doing 20% of the work, you can generate 80% of the benefit of doing the entire job. Then all of us will do 20% work and sit, relax, right? So it's not just randomly any 20% activities. It is the most important or the most critical activities to a business that we need to perform, focus on. Then 80% of the result will fall in place is the idea. For example, let's say here, I would like to see how various subcategories are contributing towards the sales of the business. Okay, and I'm going to sort the data in descending order because we want to focus on the high contributors. I would like to see how many of these subcategories collectively put together are giving Superstore 80% of the sales. So Pareto is where we focus on high contributors. Data must be sorted in descending order. And it talks about the collective contribution. So individually, phones is making a sales of $330,000. Individually, chairs is making a sales of $328,000. Storage $223,000 approximately. But collectively, what is their contribution? So these two put together, what is their contribution? These three put together, what is their contribution? These four put together, what is their contribution? Then these five put together, what is their contribution? So on and so forth. So this is called running total, cumulative total or running total. How do we get that information? Is in Tableau, you don't have to write a formula to compute running total. Again, very interesting feature. Some very frequently used requirements like getting the running total, obtaining the difference, percent of total, giving a rank, computing the percentile, moving average, year-to-date total, compound growth rate, year-over-year growth, or YTD, year-to-date growth. For these kind of requirements, the formula is already written. We just need to access it using the feature called as quick table calculation. So I'm going to access running total. This is individual performance from phones. Phones and chairs together are giving so much sales, almost 658,000, more than that. And collectively up to storage is 822 sales. When the contribution of tables come into picture, it further increases. When the contribution from binders come, it further increases. So this is how various members are contributing towards the sales. Okay, this is supposed to be a line. Now, even the individual performance should be represented. Even before that, we are able to see the running sum of sales. I would like to show this as percentages because ultimately we want to understand how many subcategories are giving Superstore 80% of its profit. All of them together is 100%. The whole sales together is 100%. But individually, what is the percentage of profit that they are contributing to, and cumulatively how much? So here there's one more very beautiful feature. After you have applied a table calculation, you get an option to edit the table calculation, modify it. And Tableau allows us to add a secondary calculation if the primary is running total. I want to show the running total as percentages, so I'll use this. How does this work? Tableau is taking the sum of sales information and applying running total formula and calculating running sum of sales. So the primary calculation is giving us running sum of sales. Primary calculation works with the data in the graph and it has given us the running sum of sales. Secondary calculation takes this information and converts it into percentages. So secondary calculation works with the data generated by the primary calculation. It works with the output of the primary calculation. It is going to take the running sum of sales and convert that into percentages. Okay. Primary calculation works with the data in the graph. Secondary works with the result coming from the primary. Now you can see everything expressed as percentages. So fonts alone is giving Superstore 14% of its sales. Phones and chairs put together are giving it 28% of the sales. Phones, chairs and storage together nearly 40% and 80% almost still here. So just a handful of members, 1, 2, 3, 4, 5, 6, 7, 8 members giving Superstore almost 80% of its sales. These are very few. This is hardly any contribution coming here, 0.03, that kind of contribution. So if let's say tomorrow I'm not able to sell products related to art or envelopes or labels or fasteners or supplies, my sales will not take a hit. Just about less than 3% sales is what I'm going to lose. They are contributing to very, very less sales. So even if I stop selling these products, business will not take a big hit. But imagine if we stop selling phones, or even worse, both phones and chairs, then 30% of the market we will lose. 30% of the sales is from these two subcategories, right? So the most important ones we can see here. The least important ones are here. Now to look at the individual contribution, I will take sales over here again and show this as bar and merge them together. For that, there is one concept called as dual axis. So I can merge two different graphs together using this concept. Individual contribution and the cumulative contribution, both we can see. So I will change the color of one of it so that you can understand it better. Okay, Pareto chart. This is actually a very advanced chart to cover at this level, but I hope you got the essence of it. Even if creation part you might not have understood, but the essence of a Pareto I hope you understood. Next, we will talk about a bullet chart. Bullets are basically used as an alternative to gauge. Gauge is like the speedometer, analog speedometer on vehicles. Now it is all digital, right? The speedometer is also digital, but some good old vehicles, they still have analog speedometers. You see a dial that would be moving depending on the speed at which you're traveling, right? The dial has some markings, 20, 40, 60, 80, 100, 120, 140, 160. Then you can see the speed at which you are moving through the dial. So bullet chart comes as an alternative to that graph. It is something where we show the target in the form of a line and the actual performance is like a bullet traveling to achieve that target. Okay, actual performance is indicated in the form of a bar. Imagine this like a bullet traveling to reach the target or the goal. So when to use a bullet chart? Bullet chart is used when you have to compare the actual performance against a target. Okay. So let me quickly show you how to create a bullet chart. So let's say I want to compare the actual profit made by the business against a target or a goal that has been set. Actual versus target, a product. So coffee chain is a business where different types of coffee and tea products are sold, like amaretto, cafe latte, cafe mocha, chamomile, Colombian, Darjeeling, etc. all of these products have made some profit. They have achieved something. Some profit is coming from each of them. And they're also given a target that they are supposed to reach. This is the target that they were expected to reach. So Amaretto was expected to make a profit of 7,000, but in reality, it made a profit of only 4,800. Now, to create a bullet chart, what I will do is, I will take the help from the Show Me panel. This is a bullet graph. So I'm going to choose profit, budget profit, and product. Tableau will help me create a bullet chart. It activates the bullet chart. All I need to do is click on it. Bullet chart is ready. Okay, I'm going to swap one small change here. Anyway, look at this. So what does this chart convey to us? So the target is coming in the form of a reference line, and the actual profit is the bar. So did the bar manage to reach the line? No, it didn't. For the first product, it could not, which means this product missed the target. It could not reach the target. It missed the target. Then you will see two different shades of gray. This is 80% of the value. If my target is 7,020, 80% of it is 5,616. 60% of this number is here, this end of the band, 4,212. So was Amaretto able to achieve at least 60% of the expected value? Yes, it went beyond the 60% mark. Was it able to reach 80% of the expectation? No. Forget about reaching the target. It could not reach even the 80% mark. That is how we read it. Look at Mint. Mint was able to reach 60% of the expected value, the target. It went beyond the 80% mark, but it could not reach the target. It fell short by a small margin. Look at Chamomile. It has gone beyond the expectation. It was expected to make a profit of 24,900. It made a profit of 27,000. It has gone above the expectation. Okay. So bullet graph is used when you have to compare the actual performance against the target. It's very easy to create it from the Show Me panel. We already talked about text table. Next is a heat map. It is something which helps us to visualize the data by representing the data as a series of squares. And we can control the size of the squares and the color of the squares. It is more or less like a text table only. In a text table, we show the data by putting the values in it. Heat map is something where instead of values, we just put square. Let's say across different regions or across different years, across different subcategories, I want to see the sales information. So I made the selection, I selected everything, and I only have to go to the Show Me panel and click on heat map. This one here is the heat map. Tableau will create it for us. I'm going to change the fit to entire view. So how do we read or understand this data? Look at the size legend. Bigger the size of the square, higher the sales. Look at copiers, for instance. Year over year, the size of the square is increasing. Means year over year, the sales is improving. Fasteners, consistently, it is a very small, tiny square. Very little sales happening from here. Okay. So we can understand about the sales. Chairs is doing good. Phones is doing good. Really big squares there. So when you express your data, show the data, represent the data as a matrix of squares, it is called as a heat map. Next, we have a waterfall chart. Now, this is also a little advanced graph to create. Okay, anyway, we'll do it. It is used to show the cumulative effect of a measure over a dimension. How different measures come together and contribute, how different dimensions are contributing towards the final value. This is called as a waterfall chart. Let's say this is the list of subcategories being sold by Superstore, and this is the profit made by the subcategories. We can notice some very highly profitable members, and we can also see that there are members which are giving us a loss. Okay, now to represent this contribution, the cumulative or the collective contribution as a waterfall chart, what is the procedure? First, waterfall is built on running total. It is built on the running total. And the basis for a waterfall chart is a Gantt bar. So I'm just going to put a bar indicating the contribution. Okay, this is accessories. Then till here is the contribution of accessories. Then appliances comes into picture. It adds to the value. Okay, and increases, pushes the profit up to 60,000. Okay, then art comes into picture. It further pushes the profit up to 66,000. Then binders comes into picture, further pushes the profit up to 96,000, I think. Then bookcases comes into picture and it pulls down the profit. It's pulling down the cumulative profit because bookcases gives a loss of 3,000, negative 3,000. So it's pulling down the cumulative profit. Like that, all of them together, what is their contribution? That is how you read a waterfall chart. Okay. Now, to give a size to these bars so that they look like a waterfall, I'm going to create one calculated field, negative counterpart of profit, and negate this. And this negative profit should be taken to size. Now you can see the size of the bars. So this is the contribution of appliances. Then starting from there, accessories, appliances came and increased the profit further. Then art came and increased the profit further. Then binders came and increased the profit further. Then bookcases came and it pulled down the profit. It brought it down. Okay. Then you have chairs, which is increasing the profit further by so much value. Copiers, which took the profit to a next level, like very high profits from here. So this is a waterfall chart. And you can also color it. I'm going to color it by profit. You can see which of them are profitable, which of them are not profitable. You can use a stepped color. You can use a different color scheme if you want. There are a lot of colors available in Tableau, and you can use a different shade of that color also. So different ways in which you can customize it a little and represent the data. So wherever I'm seeing green, it is positive contribution. Wherever I'm seeing red, it is negative contribution, like a waterfall. Now, where is the source of the water? Where is the actual measure? That can be indicated by putting the total. So if this is the total profit, how are these members coming together and finally giving us this value? This is a waterfall chart. Gantt chart. Gantt is used to show the list of activities that are performed against a timeline. It is like a project plan. It is a project plan. Let's say your team has received a project to work with. So first the manager has to come up with a plan. The manager has to list out what are the activities that you need to do, in what sequence they need to be done. And just by listing out the activities, it won't be enough. Some timelines also should be set, right? We can't take our own sweet time to complete our work. We have a schedule to meet. We have a deadline to meet. Schedule is given. So that is a Gantt chart. For example, if your requirement is to build a house, that's the project given to me, build a house. I will not randomly start off anything I want to. I will not say, okay, I'll do electricity work first. Let me finish the flooring. No, right? There is a sequence in which we have to perform. Lay down the foundation first. When am I supposed to start on it? By when am I supposed to end the work with foundation? Complete the foundation, building the foundation. Then the second activity. Let's say coming up the walls. Then the roof, fixing the doors and windows, electricity work, plumbing work, flooring work, painting work. So there is supposed to be a sequence in which we have to perform the tasks, do the activities in order to complete the chart, the work given to us, the final project. So that is what is indicated in a Gantt chart, list of activities against a timeline. Okay, here is data about various stages in a project and when are these activities supposed to start, what is the time duration given to them, and by when are they supposed to end. Given this data, I have to represent it in the form of a Gantt chart. So how do we do it? It is the list of activities, events to be performed against a timeline. Exactly when should that event start is what I need to represent. And the size of that bar will talk about the duration. Okay, this chart, to complete it, I will have to sort it. The event that is supposed to begin first will be at the top of the list. Let me do it, then I'll explain. Okay, now you see this is a Gantt chart. So first, request evaluation phase, where we check whether it is feasible for us to take up that request from the client. Then when we decide to accept the project, we go and gather the requirements from the client, prepare the requirements document, get a sign off on the document from the client. Then we start with the design document. How do we plan to approach each requirement? What are we going to create for it? Now we are not going to wait to complete design phase to start with the build. Once you are halfway through, or you've completed 75% of the design, you can start off. Another team can start off working on the graph, the coding part, the building part. Then while this is in progress, we can keep sending whatever work is completed for review. And if there are any comments, we can do the rework. Then we work on the final deliverable, which is sent out to the client. So Gantt chart is like this. It's step by step. It will tell you which activities are being performed, in what sequence they have to be performed. Is there an overlap between the activities? And by when is it supposed to end? Okay, that is a Gantt chart. It's a plan. Basically, it's a project plan. Pie chart is used to show the shares. So, okay, this is the profit made by the business. What is the share of East region? What is the share of West region? What is the share of South region? Because the profit is the profit from all the regions put together. So how is it getting divided between various regions? What is the share or the contribution of different members? Creating pie is very easy because it is there in the show me panel. Let's say across different regions, I would like to show the profit. And after selecting the fields, I will select pie chart from the show me panel. Tableau will create it for us. It's that easy. Whatever graphs you're seeing on the show me panel, they are very easy to create. You just have to choose the data members and click on the graph. So here I'm going to label it with the region. I'm going to also represent the profit from each region. So you can see the share of each region towards the profit. Okay, so this is a pie chart where we have also labeled it with the percentage contribution and the actual value. Next is a scatter plot. Scatter plot is used to show the relationship between the measures. It's like this. Okay, now let's say I have some data and I'm asked to comment about the relationship between the power generated, the power output, and the wind speed. Okay, what is there a relationship between the power output and the wind speed based on the power generated across different windmills? So after selecting the fields, I'm clicking on the scatter plot icon and I will show you the complete data. So what do you think is the relationship between the power generated and the wind speed? There's a positive relationship. There's a direct relationship. When the wind speed is less, 0 to 4 milliseconds, meters per second, the power output is also quite less, 0 to 2 megawatts. But as the wind speed increases, you can see the power output is also increasing. There is a positive linear relationship. So we can conclude that increase in the wind speed will lead to increase in the power generated. It tells about the relationship. Okay. Next is an area chart. It is used to represent how different measures are contributing, okay, towards like a line chart only. We have seen line chart, right? Area chart, just another way of representing the same data. Let's say across different quarters, I would like to look at the sales performance. Okay. And now, if I go and make this area, it is an area chart. This is an area chart. It is just the pattern is there at the same time. It just shades the area between the line and the header here and the axis here with the color. We can also break it. let's say I want to look at it by category. We are stacking multiple areas together. So contribution of technology, on top of that contribution from office supplies, on top of that contribution from furniture. So you're stacking the areas together. You can also turn off the stack marks. If you turn off the stack marks, you can see the contribution. So this is furniture, this is office supplies, and this is technology. If you want to stack them together, you stack them. If you don't want to stack them, you can just turn off the stacking. I'm going to turn it on, then they will be stacked one on top of the other. Next is a dual axis chart. So dual axis is where we will have two axes, one on either side of the graph. I want to show the profit and the target profit by products. One method is to create a bullet chart. Another method is we can also create a dual axis graph like this. So I'll do it like this. Let's say across different years, I want to show it. Not so nice. 1 minute. So various products are there. They have been given a target that they are supposed to reach, and there is some profit that they have made. Now I want to combine these together to be able to compare. So I'll just use the concept of dual axis. It's like a bar in a bar. You're putting one bar inside another bar. Okay, that bar in a bar graph. So here profit is greater than budget profit. Here the profit made is less than what was expected. Okay. Now I'm going to change budget profit into a line. This is a dual axis graph. Let's bring the line forward. So the line is indicating the target and the bars are indicating the actual value. If the bar did not manage to reach the line, it means it missed the target. Here it missed the target. This is the target and it's quite short. It fell short of the target. Here also it could not reach the target. Here it has gone above the target. That okay, dual axis is where you have two axes and you are comparing, showing the performance like this. Then we have a bubble chart. Bubble chart is where we represent the data through a cluster of circles. It's a collection of circles put together. Let's say across different states. Okay, I want to look at the sales. So I will select both the fields, and after selecting both the fields, I just have to go to the show me panel and click on bubble chart icon. Tableau creates it. So bigger the bubble, higher the sales. California is making very high sales. Followed by that is New York. Then we have Washington, we have Texas, we have Pennsylvania, very high sales happening here. Then medium sales, Indiana, Florida, Georgia, Arizona, Delaware, little bit medium sales. Then some states, very little sales, Wyoming, West Virginia, North Dakota, South Dakota. Okay, this is a bubble chart. Now, when I take a bubble chart and use mark type as text, what we get is a word cloud. Here directly we can see the name of the state. Bigger the font size, higher the sales value. Smaller the font size, lesser the sales value. Both are nice. I mean, you can create anything you want that represents such information. Okay. Histogram is used to show the distribution of numerical data. It is a chart that is used for distribution analysis. I will use another data source to explain about it. KPI is key progress indicator or key performance indicator. It is used to see whether we have gone above the target or not. That is another way of comparing the performance. Okay. So this is some information about the various CAP services. Okay. Now I want to see what is the income group of the people who are using the cab services. What is the income of the people in which groups about the cab services. So I've selected this and I'm going to the show me panel and click on histogram icon. Okay, Tableau will create the histogram for you. And if you want, you can change the bin size. Okay, I'm going to, now this is a very big concept. Histogram usually takes about 1 hour. It's just a demonstration of how to create a histogram. So I'm not getting into the details. I'll just quickly create and show it. Now look at this. This is a histogram. What does it tell us? It is telling us about the number of users, okay, and their income. So this is a bucket where people are earning 0 to 5,000, 0,000 to 5,000, 0 to 5,000 salary. And we have many users who are using the cab services with the income in this range, less than 5,000 income. Then more than 5 to 10,000 income group, 10 to 15,000 income group, 15 to 20,000 income group, 20 to 25,000 income group. So most of the people whose income is in this range, that is from 5,000 to 25,000, they are using the cab services a lot. Then people who are earning more than 25,000, more than 30,000, more than 35,000, they are not using cab services as much. They don't need it. They will have their own cars. They'll have, people who can drive them around. So high income group people are not using the cab services as much, and low income group also, they're not using the cab services as much. They will probably prefer using the public transport, trams, metros. So people who are using the cab services a lot are the people whose income is in the range of 5,000 to 25,000. So distribution of data is what it shows. Okay. So, all right, that's it for today's session. See you. Thank you. Bye-bye.